Welcome to another video from Optatube. Have you ever stopped to wonder how the lights always turn on when you flip a switch? Every single time. It feels like magic, right? Well, behind that simple act, there's this massive, invisible engine running 24/7. And today, we're going to pull back the curtain and demystify the absolute heart of that system, the day-ahead market.
Really think about that for a second. How does an entire country, we're talking millions of homes, hospitals, factories, get the exact amount of electricity it needs for tomorrow, for every single hour? The demand is always changing, right? It's a mind-boggling logistical puzzle. How on earth do you plan for that on a national scale a full day in advance?
Well, the answer is actually a pretty elegant market-based solution. We're talking about tomorrow's electricity marketplace, and we're going to introduce the day-ahead market, or DAM for short. Think of it as this giant daily auction that figures out the whole shebang: who's going to generate power tomorrow, how much, and, of course, what the price will be.
So what is the day-ahead market really? At its heart, it's the core of modern electricity trading. It's all about ensuring the optimal dispatch of power for the next day through competitive bids. Now, optimal dispatch might sound a bit technical, but think of it like this. It's the ultimate efficiency engine for the grid. Its whole job is to find the absolute cheapest combination of power plants to meet our exact needs, hour by hour. It saves everyone money by making sure we're not overpaying for our power.
Okay, so in this marketplace, you've basically got two main players. On one side, you have the suppliers. These are the generators, the power plants. They submit offers to sell their power. They say, hey, I can generate this much electricity, and this is the minimum price I'll take for it. And then on the other side, you've got the buyers, like your local utility company. They submit bids to buy power. They say, we need this much electricity to serve our customers, and this is the maximum price we're willing to pay. It's a classic setup, right?
All right, so that brings us to the big question. How do you find that perfect price? How does the market actually clear? Let's get into it.
Okay, this is where the magic really happens. The market operator, the entity running the show, takes all those bids and all those offers and basically matches them up. They're looking for that one single point where supply perfectly meets demand. You can almost picture it, right? One curve going up for supply, one going down for demand, and where they cross, that's the sweet spot. That single point is the key to the entire day.
And that intersection reveals what I like to call the two magic numbers. These are the market clearing price, or MCP, and the market clearing quantity, or MCQ. These two numbers literally dictate how the grid is going to run for the next 24 hours.
So first up is the market clearing price, the MCP. This is the single price that gets paid to all the accepted generators. Now get this, it doesn't matter if you were a cheap generator that bid really low. If your power was needed to meet demand, you get paid the exact same price as the most expensive generator that was needed. It's a uniform price for everyone who makes the cut, which is a huge part of what makes the market fair and competitive.
And the second magic number, the market clearing quantity, or MCQ, well, that's just the total amount of electricity that needs to be generated and consumed. It's the target, the exact amount of power we need to keep the grid perfectly balanced. It ensures that when you go to turn on a light, the power is actually there. Okay, so we've got the theory down, price and quantity. But how does this all unfold day to day? Let's walk through the process, from those individual bids all the way to the grid. So this whole thing runs like a well-oiled machine, every single day. First, the generators submit their bids to sell power. Then the consumers, the big utilities, submit their bids to buy power. The market operator scoops up all of these bids. Then comes the matchmaking part, where supply and demand are balanced to find that perfect price. Finally, the market results are published, and boom, everyone knows the plan. The actual dispatch, the generation of power, is then executed the very next day.
But you might be wondering, how did generators even come up with their prices? Well, as this slide points out, each generator's bid reflects its marginal cost, and strategic behavior can definitely influence the price. Marginal cost is just the cost to produce one more megawatt-hour of electricity. For something like a wind turbine or a solar panel, the fuel, wind and sun, is free, right? So their marginal cost is practically zero. They're going to bid super low. But a natural gas plant, they have to buy fuel, so their bid is going to be higher. This naturally creates what's called a merit order, where the cheapest power sources always get used first.
And here's what that looks like in practice. You've got all these different generators submitting their bids. Look at Gen 1, probably some renewable source, coming in super cheap at 22 euros per megawatt hour.
Then you have Gen 2 and 3, a bit more expensive. And finally, to meet all the demand, you might need to call on Gen 4, which is the most expensive of the bunch. Each of these is like a single Lego block building up our total supply.
So what the market operator does is take all those individual bids we just saw and stacks them up, from the cheapest to the most expensive. And that's exactly how they create one single, aggregated supply curve for the entire market. You see how it works? The first chunk of power is really cheap to get. But as our demand for electricity grows throughout the day, we have to start calling on those more and more expensive power plants. And that's what makes the curve, well, curve upwards.
So why does all this matter? I mean, this is a pretty complicated auction that happens every single day. What's the big picture here? Why do we do it this way?
Well, it really comes down to a few key insights. That intersection of supply and demand, that finds the market equilibrium, giving us the most efficient outcome. And the fact that all the accepted suppliers get the same price, that ensures both efficiency and fairness. It forces everyone to be competitive. For the players in the market, this means that strategic bidding and having accurate forecasts are absolutely critical for being profitable. And finally, the day-ahead market provides really important price signals for all the other, faster-acting electricity markets that keep the lights on second by second. You know, if you're interested in the energy market and power system modeling, and you want updates and insights about the global energy market, this is exactly the kind of stuff we talk about. So be sure to follow the Optatube YouTube channel.
So to put it all together, the day-ahead market is really the system that ensures we have a plan for tomorrow's power that is cost-efficient, totally transparent, and most importantly, super reliable.
But that leaves us with one last, really interesting question, doesn't it? If this single price is fair, and everything is planned a day in advance, what happens when the wind suddenly stops blowing, or a giant power plant unexpectedly fails and shuts down? What happens when the plan and reality don't line up? Well, that's where things get really interesting, and it's a topic for another time. Thanks for watching.